All right, guys, let's do another example. So here's F2. So 2 fluorine atoms is what I would like you guys to try. Separate them out, draw the number of valence electrons for each of the fluorine atoms, and then see how they would combine and how many bonds they would have if you were to show the Lewis structure for this. Okay, so a single fluorine atom has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Second one comes along. 1, 2, 3, 4, 5, 6, 7. Both of them have 1 electron each. That doesn't have a pair, so they can both contribute it. And therefore, we end up with something like this. 8 around the one on the right, and then 8 electrons around the one on the left. So we don't want to show the electrons that are being shared right here. We don't normally show them as dots. We like to show them as a proper bond itself. So the bond would look something like this with the other electrons around each of those fluorine atoms. So the electrons that are these ones right here that are not involved in a bond itself, we call them lone pairs. Okay, they're lonely pairs of electrons basically. Right? So now we're going to go on to larger molecules with different types of atoms. So far we've just been looking at diatomic molecules, diatomic molecular molecules. So we'll try something like CH4. Okay, and what I'm going to do here on the side is to actually write down some guidelines on how to build Lewis structures. Okay, kind of like a step-by-step thing where I can kind of guide you that do this step first, do that step next, that type of thing. Okay, so guidelines for writing Lewis structures. Okay, so I'm going to give you the molecule on the left, and then I'm going to write the steps here on the right. Okay. So the molecule that I want you guys to try is CH4. Okay, now first things first, what you want to do is count the total number of valence electrons in the entire molecule. Okay, so let's take it atom by atom. So the first atom that we have is carbon. So carbon has how many valence electrons? 4. Hydrogen has 1 valence electron. How many hydrogens do we see in this molecule? Whoops. We see 4 of them. So we're going to multiply that 1. Okay. We're going to multiply this by 4. Okay, so that's 4 plus 4. We have a total of 8 valence electrons. Okay, so that is step number 1. You should always start by counting how many total valence electrons you have in the molecule. Step number 2, draw the framework of the molecule. Now, when we build the framework of the molecule, there are a few things to kind of keep in mind, and I'm going to write those down as sub-steps in step number 2. First step is to always make sure that if you have hydrogens in your molecule, hydrogen is always an outer atom. Okay, kind of an unsaid rule is carbon is a central atom. Carbon loves being in the middle. Carbon does not want to be on the side, and carbon always loves 8 electrons around it. They could be single bonds, they could be double bonds, they could be triple bonds, but carbon loves being in the middle. Okay, and hydrogen is always an outer atom. All right, So let's build the structure for the framework for this molecule right here. So following these two rules, carbon is going to be the central atom. I have 4 hydrogens. So I'm going to place a hydrogen on each of the 4 sides of carbon. Okay, so that is my starting point. That's my framework. So that's going to be step number 2. Step number 3, I'm going to leave some space here because I'm going to add some more points to this. Step number 3 is to add electrons to form bonds between atoms. And remember, 2 electrons make 1 bond. Okay, and that's why we counted our total number of electrons in the very beginning. So that means we should not be going past the total number of electrons that we counted to begin with. Okay, so following step number 3, we're going to make bonds between our atoms. And remember, 2 electrons make a single bond. So let's start. 2 electrons, that's 2, 4, 6, 8. Right? I made 4 bonds and I used 8 electrons to make those 4 bonds. So now what I do is I go back here, I subtract 8 from my total valence electrons because I used all 8 and I'm down to 0. And this is looking pretty good. So that means I've used all of my valence electrons that were available to me. I have nothing left over. Okay? So after you've done this, after your number has come down to 0, you're going to go back to your molecule and you're going to double check to see if all of your atoms have a complete octet. Okay, so check for complete octets. And remember, with octets, hydrogen is an exception because hydrogen is happy with 2 electrons only. Okay, and boron is happy with 6, but every other atom needs 8 electrons. So let's count. This hydrogen has 2 electrons in the bond, this one right here. Then this electron has 2 bonds in the shared bond. This hydrogen has 2 electrons in the shared bond, and then this hydrogen has 2 electrons in the shared bond. So all my hydrogens are happy. Well, what about the carbon in the middle? I've got 2 here, 4, 6, and 8. All 8 electrons are around that carbon. Carbon has also completed its octet. So this structure right here is a good Lewis structure. Okay, and that's it. CH4 is done. All right, so we're going to try more examples. All right. The next one we're going to do, so if you guys haven't written those guidelines down, I suggest you write them on a piece of paper so you can follow them along as you build your structures. Let's do HF. Okay, so pause the video, follow those first 2 steps at least, and then we can come back and you can check what more we need to do because I'm going to add more information to those steps. All right, so step number 1 was count the total number of valence electrons. So for hydrogen, we have 1 valence. For fluorine, we have 7. A total of 8 valence electrons. We're going to build a framework. So in this case, we only have 2 atoms, so we can literally just place them side by side. You can put the hydrogen on the left of the fluorine or above the fluorine or below the fluorine. It doesn't really matter. Okay, I'm just going to follow it the way the formula is written. All right. So I've got my electrons, I've got my framework. Step number 2 is to make enough bonds in there. So put enough electrons to make bonds between your atoms. There it is. I used 2 electrons, right? So minus 2, I'm left with 6 electrons. Well, let's check to see about our octets here. Hydrogen has 2 electrons in this shared bond, so hydrogen's happy. But what about the fluorine? Fluorine so far only has the 2 electrons in the shared bond, so fluorine needs more electrons. And guess what? We've got 6 electrons still sitting here that we can use to complete the octet for fluorine. So let's add another step. Add enough electrons as lone pairs to each atom to complete the octet. Okay, and in this one, there's kind of like a sub rule to this one. When we get to larger molecules, it will apply, starting with outer atoms first. Okay, so you kind of start putting lone pairs around the outer atoms, and then make your way in. And then if you have central atoms that need electrons, then we have to modify them. Okay, so let's put our lone pairs. How many lone pairs does fluorine need to complete its octet? We need 6, right? So 2, 4, 6. I'm going to go back to my count, subtract 6, and we're left with 0. Okay, is my octet complete for both my atoms? Hydrogen, yes, it only needs 2, so it has that. Fluorine has 3 lone pairs with 6 electrons around it, plus the 2 in the bond, so that is a complete octet for fluorine. So this is a good Lewis structure for fluorine. Okay, let us try NH3. Okay, so start following the steps and then see if you can build that Lewis structure. Okay, so first step is to count the number of valence electrons. So we have hydrogen, single valence electron and 1 hydrogen. There's 3 of them. And then we have nitrogen, which has 5 valence electrons, a total of 8, okay? And yeah, the molecules that I'm giving you guys are showing up with 8 valence electrons, but that's not always the case. So don't kind of take that as an assumption, okay? You should always count them. All right, step number 2 is to build your framework. So in that framework, remember, you want to always put hydrogen as an outer atom. All right, so we're going to place nitrogen in the middle. And there are 3 hydrogens, so it doesn't matter how you put them. You could have one on the top instead of the one on the bottom, doesn't really matter to me. Okay, but I'm going to place mine like this. So 3 hydrogens around that nitrogen. Step number 3 is to add enough electrons to make bonds between your atoms. So let's count as we put those bonds in. 2, 4, 6. So 6 electrons used up. I'm left with 2. All right. Am I completing the octet for all of my atoms? Hydrogens are happy because they all have 2 electrons each in that bond, but nitrogen has only 6 electrons in those 3 bonds. So nitrogen still needs another pair of electrons, and I have 2 left over. So remember, step number 4 is to complete the octet. So I'm going to put 2 electrons right here on the nitrogen, subtract 2, we're left with 0. So that's 2, 1 lone pair for nitrogen, and then 3 bonds, that's 8 electrons for nitrogen, and then each of my hydrogens have their complete quote-unquote octet as well. So this is now a good Lewis structure for ammonia, NH3. Okay, I'll stop the video here and we'll do more examples in the next one.